Hi guys, in this video, I'm gonna do a machine learning project and talk about linear regression model. For this project, I'm gonna use medical cost personal dataset. After building the model, we'll enter the patient information such as age, sex, region into the model and then predict the patient charge. This is a simple application, but it will be excellent project for an introduction to machine learning. In short, what I will talk about is how to do pre-processing. Next, I will explain how to build a linear regression model and how to evaluate the model. Finally, I will show you how to predict a new data. Before getting started, we create videos in the fields of AI, data science, machine learning and deep learning. So, to get the latest videos, don't forget to subscribe and press the bell icon. Let's go ahead and start the project. Dataset I will use include charges from patients. You can access this dataset from the link in the comments below. I highly recommend that you download this dataset and write your codes with me. At the end of the day, you can understand very well just by watching. First, let's import the dataset. I'm gonna load the dataset using pandas. Let me first import pandas. Import pandas as pd. Pandas is excellent library for data loading and data preprocessing. You can find detailed tutorials about pandas on our channel. Now let's load the dataset with the read CSV method. Data equals pd.read CSV. Let me set name of data. Insurance CSV. Okay, we have loaded the dataset. Now let's see the first rows of the dataset. To do this, I'm gonna use heat method. Data.heat. As you can see, there are 7 columns such as age, sex, body mass index, number of children, smoking, region, and charges. Okay, understanding the dataset is very important before building the machine learning model. For example, let's see the number of rows and columns of the dataset. I'm gonna use shape for this. Data.shape. As you can see, the dataset has 1328 rows and 7 columns. Now I am gonna use info method to get more information about the dataset. Data.info. As you can see, there is no missing data in the dataset, right? You can also use isNull method to see the missing data. Data.isNull. To see the sum of the missing data, let me use the sum method. Sum. As you can see, there is no missing data in the dataset. The structure of the columns is very important in machine learning. Now, let's see the structure of the columns. I am gonna use dtypes for this. Data.dtypes. You can see types of the columns. If we pay attention, sex, region, and smoking object type. Let's convert them to category to use the model building later. Data. After that, let me select sex equals data sex dot as type category. Let me copy this and paste. After that, I am gonna edit the other variable. Region. Let me copy again and paste. I am gonna edit for smoker. Let's see the data structures again. Data.dtypes. As you can see, the data structures of 3 variables become categorical. Meanwhile, you can access these notebooks from the link I leave in the description box below. Okay, now let's go ahead and see the statistic of numerical variables with the description method. Data.description. Note that you only see summary statistics of numerical variables. If I take the transpose of the dataset, you can see the statistic better. Let me .t. Now, let's look at the mean charges for smokers and non-smokers. To do this, let's first group with the group by method. Smoke data equals data dot group by. I'm gonna select smoker column. After that, let me set mean. I'm gonna use the round method to see only 2 numbers after the comma. Let me set round and I'm gonna write 2. Let's see smoke data. As you can see, Smokers pay more than non-smokers. With data visualization, we can understand the dataset better. Now, let's look at the relationship of numeric variables using the Seaborn. First, let's import Seaborn. Import Seaborn SCNC. Seaborn's library that it builds on the Matplotlib, especially used for statistical graphics. Now, I want to choose the graphics style. To do this, let me set CNC dot set style. I'm gonna write white grid. Now, let's use the pair plot method. CNC dot pair plot data. Let me set variables age, BMI, charges, and then for hue argument, let me set smoker. For height argument, let me set 3. For palette argument, let me write set 1. I got an error. Error is about smoker. Let me set smoker. I'm gonna run again this cell. You can see pair plot. For example, when you look at the age and charges graph, you see that as age increases, both smokers and non-smokers pay more. Now, let's look at the correlation between the variables. To do this, let me set CNC heat map data.core, and for anode parameter, I'm gonna set true. Notice that there is a relationship between charges and the other variables. Now, I'm gonna prepare dataset for the model. First, let me do one hot encode the category variable in the dataset. Otherwise, you'll get an error message while building the model. You may ask that why we do this. There are category variables in the dataset, right? Let's see them again first. Data, dtypes. These category variables have subcategories. We need to convert this category data into a form that the scikit-learn library can understand. For this, we need to do one-hot encode category data. This is very easy to do with pandas. We can automatically convert category data to one-hot encoding using the getDummies method in pandas. What does one-hot coding do? For example, let's consider sex variable. With one-hot coding, separate columns for man and woman are created. And if the patient is a woman, the woman columns set 1. And if the patient is a man, the man column sets 1. In other words, with one-hot coding, a column is created for each subcategory for the variables. This increases the number of columns. If you want, let's look at the column names. To do this, data.columns. As you can see, there are 7 columns in the dataset. Let's convert categorical data to one-hot encoding. Data equals pd.getDummies data. Thus, only categorical data were converted to one-hot encoding. Now, let's look at the columns of dataset. Data.columns. As you can see, new columns have been created for each subcategory. Using pandas, this was very easy. Thanks pandas. You can also do one-hot encoding with the scikit-learn. Thus, I made the dataset ready for model building. Data processing takes the most time for machine learning engineers or data scientists. Let's go ahead and build the machine learning model. When building a model, remember to start with the simplest model. If you don't get good accuracy, you can try more complex models. In this video, I built a linear regression model because the output variable charges is number type. Before building the machine learning model, we need to determine the input and output variables. Remember that input variables are attributes. In statistics, these are called independent variables. The output variable is the target variable. In statistics, this variable is called the dependent variable. Let's assign the target variable charges to variable y. To do this, y equals data charges. The other columns will be attributes. If we drop the target variable, the remainder are the input variable. X equals data drop charges axis equals 1. Okay, we determine the output and input variables. Before the model is built, the dataset is split into training and testing. The model is built with the training data and the model is evaluated with the test data. We can use train test split method in the scikit-learn to split dataset into training and testing. With this method, you can easily split the dataset. First, let's import this method from sklearn.model selection import train test split. Let's split the dataset into 80% training and 20% testing. X train, X test, Y train, Y test equals train test split. Let me set first X and then Y for train size parameter. Let me set 0.80. I am gonna use the random state parameter for deterministic sample. Let me write 1. Thus, the dataset was split into training and testing. As you can see, we can easily perform model operations with the libraries such as pandas and scikit-learn. Now, let's build the model. Let me import the linear regression class from scikit-learn. From sklearn.linear model import linear regression. Let's get an instance of the linear regression class. LR equals linear regression. Let's build the model using the training data. lr.fit. Let me write X train, Y train. That's it. Let's take a look at the performance of the model. To do this, I am gonna use the coefficient of determination. The closer this value is to 1, the better the model. First, let's see the accuracy of the model on the test data. To do this, let me set lr.score X test, Y test dot. I'm gonna use round method. Let me set 3. You can see the accuracy of the model on the test data. The coefficient of determination on the test data is greater than 0.7. We have built a good model. Of course, it would be better if it was closer to 1. Now, let's see the accuracy of the model on the training data. To do this, let me copy this code and paste. I am gonna edit train data. As you can see, the accuracy of the model on the training data is close to accuracy on the test data. If the accuracy of the model on the training data was high, it would mean that there is an overfitting problem. You may ask how to solve overfitting problem. To overcome the overfitting problem, you can use regularization. Rich or lossy models can be used for this. Now, let's take a look at another metric, mean secure error, to evaluate the model. For this, let's first predict the test data with the predict method. ypred equals lr.predict xtest. Now, let's import the mean secure error metric from sklearn metrics import mean secure error. Let's use this metric now. First, let me import the math module because I'll take the secure root of this metric. Import math. Now, let's calculate the secure root of the mean secure error. Let me set math secure root mean secure error. Let me set y test ypred. You can see the metric. This value means that the model predicts with the standard deviation of 5641. Now we can make predictions. I'm gonna predict the first row as an example. First, let's select the first row of training data. Data new equals x train 1. Now let's predict the data according to the model we have built. lr dot predict data new. Predict is written on the screen. So let's see the true value. Y train 1. As you can see, our model predicted close to the true value. Machine learning is an ocean. I love machine learning. In this video, I showed an application using a real-world dataset. As you can see, it is very easy to build a machine learning model with Python libraries. If you have any question, please write it in the comments below. That's it. I hope you enjoyed. Please don't forget to subscribe, press the bell icon and like the video. See you in the next video. Bye for now.